Here is the next question. What are the different checks that we perform in the CTS stage? CTS, which stands for clock tree synthesis, is a crucial step in the physical design. Its primary goal is to distribute the clock signal evenly and manage the load balance throughout the design. Here are some of the quality checks that we perform before the CTS as well as after the CTS. Some of the pre-CTS checks are: check whether the tool has completed the placement of the standard cells and its optimization by verifying the placement legality. Followed by check for the pre-routed power and the ground nets surrounding the core area for the distribution of supply from the outside world to all the cells in the chip layout. Followed by the next check is for the acceptable congestion levels, because congestion can lead to detours, longer routing paths, and potentially the worst results in terms of timing, power, and area. And the next check is for the acceptable timing. Now, what is acceptable timing? It refers to ensure that the circuit meets the specific timing constraints like setup time and hold time constraints without exceeding the limits of max transition and max capacitance. And the next check is whether the high fan-out nets such as the scan enable and the reset were synthesized with buffers or not. Because the high fan-out nets are the nets that drives numerous number of loads in the design. So these nets can pose challenges during the physical design process due to the need to connect all the loads in the design to the drivers, which requires significant routing resources. Additionally, meeting the timing requirements on the high fan-out nets can be difficult because the loads are dispersed throughout the design, resulting in higher net delays. Since the load is proportional to the delay, buffering the high fan-out nets helps to balance the load and improve the overall performance. And the final check is for the clock source so as to generate the clock signals to all the sequential elements. These are all the pre-CTS checks. Now, some of the quality checks that are also performed after the CTS, that is after distributing the clock signals to all the clock pins of the flip-flop. Now, the first check is whether the insertion delay is minimized or not. Actually, the CTS aims to minimize the insertion delay introduced by inserting the buffers or the inverters along the clock paths. So by balancing the clock delay, it ensures that all the clock inputs receive the signal at approximately the same time. The next check is for skew balancing. Skew refers to the variation in arrival times of the clock signal at different clock pins of the registers. Actually, the CTS strives to minimize the skew by adjusting the placement of buffers or the inverters on the clock paths. And the next check is for the timing constraint verification. Verify if the timing constraints, especially the hold time, are met after the CTS or not. Then the check is for the utilization of the standard cells and the clock duty cycle. Actually, the utilization of the standard cells must be within the acceptable limits, because high utilization can lead to congestion and routing difficulties. Now, with respect to the clock cycle, the pulse width of the clock signal should be within the acceptable limits. So, after the CTS, check has to be performed for the pulse width and adjust the width as needed. Now, the next check is to minimize the clock tree power consumption. Actually, the CTS considers the power consumption during the buffer insertion because the clocks consume a significant portion of the chip power. So, it aims to minimize the power while maintaining the signal integrity. And the final check is on the signal integrity and the crosstalk. The CTS checks for the signal integrity issues caused by the parasitic capacitance and the resistance of the nets, such as noise and the crosstalk, which can affect the clock distribution. So these are all the post-CTS checks that we perform during the CTS stage.